Let's move over to number 30. Which of the following is a polynomial factor of 4x squared plus 13x minus 12? For this problem, we are going to go ahead and factor it. So I'm going to factor it the long way. 4x squared plus 13x minus 12. Multiply 4 times negative 12. I get negative 48. And we have to find the numbers that add to 13. 1 and 48. 2 and 24. 3 and 16. Remember, 1 always has to be negative. Negative 3 will work. So this one stays the same. 4x squared, negative 3x plus 16x minus 12. Again, the first one stays the same, last one stays the same, the middle two is split. GCF in the first two, I can pull out an x, and I'm left with a 4x minus 3. GCF in the next two, I can pull out looks like a 3, a 4. And I'm left with a 4x minus 3. Remember, these have to match. So I have a 4x minus 3 is one of the factors, and then x plus 4. So which one is a factor? 4x minus 3. The answer is D. Alright, moving on to number 31. Okay, because we have two variables, x and a y, this is going to be a system. So let's write it over here. X plus y equals negative 6. And x minus y equals negative 3. Okay, since I both have a positive y and a negative y, I can just add down. I get 2x equals negative 9. Okay, so x is negative 9 halves, or negative 4.5. Okay, I can go ahead and plug it back in. So my negative 4.5, I can go ahead and plug in for x and figure out what y is. So I can get x squared minus y squared. So let's see, negative 4.5 plus y equals negative 6. I'm going to add a 4.5 to both. And it looks like I have 2.5. Negative 2.5. Negative 1.5. Oopsie. Now I have what x and y are. I can go ahead and plug them in. And rewrite this. X squared is negative 4.5 squared minus negative 1.5 squared. And solve. So it looks like I have 20.25 minus 2.25, which is 18, and that's my final answer. Alright, number 82. We have x minus y, quantity squared equals 35, xy is 41, then x squared plus y squared. Okay, this one's kind of tricky. Remember, in algebra, if you have x minus y squared, you cannot distribute like this. That would be wrong. Okay, what you have to do is FOIL. So remember, FOIL makes that smiley face. First inside, outside last. X times x is x squared. Outside, negative xy. Inside, negative xy. And last, plus y squared. Okay, these two can combine for x squared minus 2xy plus y squared. And we know this is 35. Okay, the problem gives us that xy equals 41, so I'm going to plug in the 41 right there, substitute it in. X squared minus 2 times 41 plus y squared equals 35. 2 times 41 is 82. X squared minus 82 plus y squared equals 35. Go ahead and add the 82. So I have x squared plus y squared equals 117. And that's all they wanted. They wanted to know what x squared plus y squared was. Moving on to number 33. Consider the true statement. If it's over 100 degrees Fahrenheit, then we're out at 4 p.m. So if they're already telling us it's true, hypothesis and conclusion. Hypothesis is the part after the if. It's over 100 degrees Fahrenheit. And remember the conclusion is the part after the then. We're out at 1:40 p.m. Okay, inverse, converse, and contrapositive. Let me make more room really quick. Alright, converse is the statement switched, the if and the then is switched. Inverse is when we add the nots. This is switch. And contrapositive, you do both. So, converse. If we're out at 1:40 p.m., then it's over 100 degrees Fahrenheit. Inverse. If it's not over 100 degrees Fahrenheit, then we are not out at 1:40. And contrapositive, we're going to switch the statements and add the nots. If we're not out then it's not 100 degrees Fahrenheit. Okay, let's look at the true and false. Remember, if the first one's true, the original true, then the contrapositive is also true. Okay, original and contrapositive. If we're not at 1:40, it's not 100 degrees Fahrenheit. And if we're out at 1:40, then it is over. So look at this one, the converse. Is that always going to be true? Not necessarily, so we're saying this one is false. We could be out at 1:40 for early dismissal, but not just because it's over 100 degrees Fahrenheit. These two are also the same. Okay. 35. Consider the following two logical statements. If the length of AB is 2, I'm going to draw a picture. The length of BC is 5. BC is 5. Then if the length of BC is not 5. So this is my original statement. And what they're giving me here is they're flipping it, they're moving this first, and they're adding a not, which would be the contrapositive. So what would be the leftover part of the statement? If the length of BC is not 5, then the length of AD is not 2. Okay, so both statements are true. It follows the length of AB is not true, because we have to rewrite the contrapositives. Moving on to the proofs.